everyone, welcome to the live stream.
Hi, I'm Carlos.
I'm Submarine. This is episode 139, which is actually our 40th episode, and we're going to go over how to start programs on boot, which I know very little about, so I'm going to pass it over to Carlos.
Yeah, so for a lot of users, we haven't actually specified a way to start processes on the Raspberry Pi. So if you look at a script, we just kind of left that to the user to decide because that was more of a Raspberry Pi thing. But we felt like it would be nice to have a video to show how we can do this, and we're going to be using systemd on the Raspberry Pi, which is just a system and service scheduler manager. Manager. And yeah, it'll just show you how to start scripts on boot, and that'll easily let you just say, like, you can start Google Assistant on boot, any custom projects on boot, and also have them restart if they crash on boot as well.
Yeah, and that's like really helpful. It's been helpful for us at demos. When you have your own projects at your home, you just plug it into power, it'll start, and you just interact with it. So it's plug and play, right?
Yeah.
All right, so should we move to the screen?
So
All right, swapping over.
All right, so let me clear that up. So we actually have a GitHub repo with a couple of examples. So we have just really simple examples for Bash, Node, and Python. So we're going to show you all three. And you can the way we do this is that systemd to add services, you have to add it to a folder it was like / here. I'll show you right now. So all your services are going to be in this folder. So let me load it up /etc/systemd/system. So all services are in here, and we're going to add services in here for anything we want. So that's what I'm going to show you right now. So first off, you're going to clone this repo. And this is a boilerplate repo, so you don't have to follow it. It's just to give you like a quick example or like an easy setup to follow. So I'm going to clone the repo and go inside. And then once I'm inside, I'm going to, there's a bash script inside, so I'm just going to make that an executable real quick.
So this example you're going through right now is how to make a bash script run on boot, right?
Well, I'm doing all three at once. I'm just making the bash script an executable.
Oh, okay.
That way I can actually call it. Like if I look at it right now, the bash script on here, it's just a loop that prints looping every second.
Gotcha.
That's what all three scripts do. They're not meant to do anything fancy. So I'm going to clear that. All right, so then we're going to change the permissions on all the service files. So what this does, 644, is that the user can read and write, and everything else can read. We probably don't really need this because of the way I set up the service, but it's just more of a precaution to make sure everything works okay. Okay, and then once we set the permissions, we're going to create symbolic links. So the reason we're making symbolic links is that normally you can just bring it into systemd, like that folder, and just drop your services there. But if we make a symbolic link, that means that we can edit them in here in our home folder, nice and comfortably, all grouped up. And all the changes we make here automatically go over to systemd. So if you actually go back and look at that directory, you'll see that all the examples we have are copied over, or linked over.
Okay, is the reason they're a different color because they're symbolic links? Just curious.
I'm not really sure what what that's for.
Cool.
So what that means, symbolic links, is that any files we edit, so if I do, here, if I edit, say I guess like the bash example. Oops, sorry. Service. So anything I edit in here, sorry. How do I go back?
I think, yeah.
Okay. Yeah, so anything I edit here, so I'm just going to put like, I don't know, running. This is a really easy change. If I actually look inside the systemd folder, I'll actually see the change. So that's what a symbolic link does. Makes it really easy. It's kind of like a shortcut, if you know what that is. So let me...
So bash.
Yeah, bash. Service.
Example.
Oh,
bash,
yeah, sorry.
Yeah.
Bash example dot service. Then you see the change I wrote is
running.
there.
Okay.
Yeah.
So you change it in your home Pi folder, it'll change in the systemd system folder.
Yeah, so this is a setup I like to use because it makes it a lot easier to know what because if I just dropped it in there, I might forget what services I wrote and which ones are already there from the system. So it's just handy to group everything together like this. So having it all in here, I can see, I know which services I made and what they're pointing to. It basically just for organization. You don't have to make a symbolic link.
Yeah,
you can just drag and drop a service. But that's what this template's for. So now that we've made a symbolic link, we're pretty much good to go. All the services are loaded. If I want to start one, this is a really simple guide. So I can just do sudo systemctl, and this command controls systemd. to like all the services going on. Start, and I get to say the service, say like bash example dot service.
Okay, so now it's running?
Yeah, so it's actually running in the background. So if I do, instead of start, there you go. Instead of start, if I do status, I can actually see what's going on. So here.
Okay, looping.
Yeah, and you can see that it's still looping in there.
So if this were, instead of like just a simple bash program printing looping, doing some like the snip services, for example, voice assistant, are all systemd services.
I mean, I haven't checked, so
the error logs would print if you do status, you know?
I mean, it depends. It depends on how the service is set up. But this is just for like your own custom apps.
Okay.
For the most part. And just to show you that it works for the for JavaScript and Python, I'll also do it for those. So instead of bash example, I'll use the Node.js example.
Is that what you called it?
Oh wait, I put status. My bad.
Because you haven't loaded it yet.
Yeah.
So you have to start it.
Yeah, you have to start it. Well, I mean, you can still look at the status, but it won't start. So see, if I do this right now, I can see that it's doing a simple loop. And yeah, so if, the way this is set up, if you actually look in here, let me open up the GitHub. So any .service file right here.
Do you want to zoom in a bit to the GitHub, just a little?
Yeah, I'm gonna do that right now.
Okay. Perfect.
Yeah, so these .service files are like really minimal. The ones for this example, we set the user as Pi, so all these commands are being run by the Pi user. The quick description. Here's like really the thing most people are gonna look at, the command to run when the service starts. So you can actually specify when a service starts, like if at one point in time the system it starts, so like after the network stuff is loaded, for maybe like you want to run a server on start. And also like when to restart a service. So in here, it'll only restart when there's a failure, and after it fails, it'll wait 5 seconds before restarting.
Okay. So if someone were to edit this to like be the name of their own bash file, they would just edit the exec start line, right?
Yeah. So you just point to whatever file you want, an absolute
path.
An absolute path to where your files are. So if I go back, so this one doesn't. So hold on. So the bash one is simple, and for the Python and Node.js one, I've added to tell it to start after the network is ready. So right here, after equals network.target, that waits for all the network services to start, and then it runs it.
Okay, I mean, need the full node path for Node.
Yeah, so for Python and Node, you need the full path of the executable. So for Python, it should be in user bin by default, because the Raspberry Pi comes with Python 3 installed. I think, right? If not, you can install it and it'll have the version there. For Node.js, we install it through NVM, so I'm going to assume that you have it installed through NVM, and I wrote a comment here to show you how to find the path you need, as well as what the path looks like for me. So in this case, I'm using Node 12.11.0. You can just check which one you have installed and just change the numbers, and you're good to go.
There's also a neat trick you taught us with the node which thing, which we should just say. I think it's cool.
Yeah, you could also what was it, which node?
I think it's which node. Yeah.
Yeah, you can also type in which node, and it tells you the exact path over here, which is just handy to have. So I'm going to clear this up. So I'm going to stop these services real quick. So we have the basic building blocks for a service. So I'm going to actually create a matrix service. So actually, once you have a service ready, you can have it start on boot by like a simple command. We have a couple of commands here on the bottom that show you how to start a service, how to stop, how to restart one, and enable and disable let you. If you enable service on boot, on system boot, it'll start up. So if I unplug the Raspberry Pi and plug it back in, the service will restart
automatically. Like you don't have to do anything.
Yeah, no hassle. It does it by itself.
Mm-hmm.
So I'm gonna quickly set up a script in Node.js for the creator to have the LED spinning around, and that'll just be a really quick example. So npm init. Hold on. I'm just gonna do init-y. There we go. Install our JavaScript library. So it's, let me see, at matrix.io/matrixlite, and save that. Nope, it's like a mosquito here.
Yeah, I know.
So that'll install the libraries. That'll be like a good 30-20 seconds for it to download and compile everything.
Yeah, Matrix Lite is a super nice. Yeah, that's a good idea to show. A super nice library. So there's a mosquito. Super nice library because it's like the syntax is really easy. Whether you're using JavaScript, Python, or Go, depending on what your interests are, it's also really easy to download and program. So
Yeah, so right now I just went to our documentation and pulled up the Everloop example, which is basically just a rainbow spinning around. And we're going to copy that. So we're going to have that start on boot, and that'll just be the final example to leave this video off with. And also, if you need to understand, if you want to know more about like what kind of configurations you can make, I added a link here for helpful.service options. So here you can look at all the parameters and like options you can add to your service file to say like, oh, when do you want it to start? What kind of service are you making? What it conflicts with? And like, there's a ton of options that goes beyond the scope of the video, but it's good for anyone that wants to dive in.
Mm-hmm.
So, okay, we have made the script, so ls. So I'm going to edit the node example that we have. So nano node, oh, my bad. Oop.
Node example.
Yeah. There we go. So this is the example we have. So I'm going to delete everything in here. Paste the rainbow example. Oh, there we go.
Yeah.
Yeah, I'm not used to Mac again.
Yeah.
Okay, so if I do this and run it just to make sure it works.
A node example.js or
yes.
Yeah, cool.
Actually, just you don't actually have to have JS for node.
Yeah.
So if I run that, there we go. Rainbow's going.
Love the rainbow.
Okay.
Every time.
So the rainbow's working. Now we're gonna start the service like that. So
while you start the service, I'm gonna hold this up. So the program, he stopped it, so it's paused. But when it starts, it should theoretically go.
There you go. So now that we know it starts from the service, we can enable it to do it on boot. So I'm going to stop the service. And then I'm going to enable it. There we go. So, yeah, there we go. So now that it's there, I can just do sudo reboot. Enter.
Okay, so we're rebooting.
Yeah. So it's going to take a little bit of time for it to reboot and like get all the processes out of the way. And then you'll see the rainbow start over again. So just give it a couple seconds.
Yeah, but it is really cool. What's nice about this is, say you have a voice assistant controlling your lights in your home or something, and you like programmed it, everything, you plug it into, like we have in the office, like a voice controlled light switch, and it starts on boot. What's nice about that is you plug it in, it works. If it fails, it'll like restart. Or you can just, so you can just unplug and replug and it'll restart on boot. So it's less work for you to keep having, you don't have to SSH back into it. It just starts automatically.
So I'm going to look at the status real quick. Oh, there was a failure here.
Oh, no.
Oh, wait, there you go? No.
Oh, wait, here it is. It's going.
Oh,
so I think it just took a bit.
Yeah, so what could have happened is that there were some of our matrix packages probably weren't ready. With like flashing the FPGA and everything, which is a really nice part about having it restart. So in case it starts too early, I told it, oh wait, 5 seconds and then restart, which makes it so that you don't have to worry about, because normally there are other ways to have your script start on boot, but the issue is that there's not a real easy way to tell it, oh hey, wait for all these things to be ready and then run the script. Because before we used systemd, like we had users going to edit like rc.local or make a cron tab job. And what that happened was that they'd put like a sleep 30, so they'd wait 30 seconds and then run it. But in this case, we're guaranteed to have it work, which is it's a cleaner alternative to those.
Right.
So,
because it tries to restart on failure, if like the matrix packages haven't loaded before it starts, it'll just restart after.
Yeah, and you can just tweak it to get a bit closer to like when it's okay to start. And play around with all the options. This is meant to be a boilerplate so that any user can just set this up and have something running on boot and not have to worry about it.
Yeah.
Right, so let's move back there.
We're ready to come back. Let's see. Right here. All right. Well, that was great. I had a lot of fun. Starting stuff on boot is really like helpful especially when, for our demos, it has been great. All we have to do is like put Wi-Fi on them and then plug them in and they work. Most of the time. It also depends on the Wi-Fi connection for things that do need Wi-Fi, but it's like super helpful for if you have a project running in your home like on a daily basis, or you're going somewhere and you're trying to show people a demo. So yeah, I think that's all.
So that pretty much covers the video. If you need any help, feel free to make a PR or an issue on the repo. We'll link it in the YouTube video as well as a link to our community and docs. And yeah, that pretty much covers everything. I hope you enjoyed episode 139, our 40th episode. And yeah, have a good weekend.
All right. Bye, everyone.
Bye.